Welcome back, boys. How are you?
Good, right.
It's been a week since we last seen you. Remember last week we were doing identifying hazards with brakes. This session today we're going to be identifying the tools and equipment for inspecting and servicing light vehicle brake systems. Okay, that's the unit we're going to cover today. So I'll hand out the student attendance record sheet if you all want to put your details on there. Thank you, Brian. You can kick off. How's everyone been?
Good, thank you.
It's a bit cold today, so I've got the beanie on. Apologise in advance if that's causing anyone distress. However, I've got to keep my head warm. I like to be warm. So today's outcome, what we want to achieve is that we identify and know what tools are required when we're working with brakes and how to use them properly, how to read them. So whilst we're handing that around, we'll just be talking about that. So, has anyone worked with brake pads? Anyone changed their own brake pads, mum and dad's brake pads? Best friends, sisters, uncles, cousins, brake pads? Yep. So how did you push the pistons back?
There's this tool that has like a flat surface and then you wind it in and it pushes the thing back.
Oh, one like this
Yeah,
one?
that.
Okay, righto. So that's our piston wind back tool. You can use a G-clamp if you had to.
Well, there's wind back pistons, so you have to like spin.
Oh, they would, okay, yep. I know the ones you're talking about. The pistons are actually on a thread and you've actually got to turn them back in, so you actually need the proper tool for that. Yep, good one. Thanks, Seth. Ryan, done any brake work?
Yeah.
No? Yep. Okay, so what's the number one hazard from last week? What's the number one hazard for brakes?
Brake dust.
Brake dust, yeah. What can it do to you?
Damage your lungs.
Damage your lungs. Yep, you'll have breathing difficulties. How do we contain that? How do we make sure it's safe to work on?
Wet.
Wet cleaning.
Yeah,
Well done, Brian. And when we mean wet cleaning, it doesn't mean we go and drive in the puddles. We take it off, we hose it all down, we contain it in a drain tray so that we can dispose of it in the proper manner. What other things have we got with brakes? Chemicals? Where would we find the information on that?
Yes.
SDS, safety data sheet. That will tell us all the hazards. And that's what we went through last week. So good on you for remembering that. I know it's been a week. We've had a lot going on. But just make sure we're wearing our PPE, safety glasses when you're dealing with brake fluid, nitrile gloves. You want to keep your hands clean as much as possible anyway, so you don't dirty the car, touch the interior. You don't want to get anything dirty or anything like that. We'll just wait for Seth to finish up with his attendance record and then we'll move on. But anyway, well done guys, it's excellent. Memory retention, fantastic. Rightio, so we'll move along. We'll go through this PowerPoint presentation. So we've got basic hand tools. We've got socket and ratchet sets. Obviously we've got to undo bolts, nuts, so socket and ratchets. Just that's what you would normally use. Probably impact sockets. We don't want to be ripping on it with power tools, impact guns or anything like that. Just sockets and that are basically good enough. Screwdrivers, we sometimes have to undo backing plates, or the rear drums on drum brake systems are sometimes held on with Phillips head screws, and they can be quite hard to get off. Sometimes you will need an impact screwdriver to get them off. So we've got to be, got to have the proper screwdrivers as well. Specialised pliers. So some of those rear springs on brakes, they're quite hard. Those springs that pull the brakes back in can have a lot of tension on them. They do make special pliers for them. So just be aware of that. And they also make special tools for undoing the retainers on brake drums. Another thing we need, torque wrench. So every nut and bolt on a car has a specific tightening torque. So we've got to make sure that we're going to be tightening the bolts up to the correct tension. Where would I find that information? How do I know how tight I need to tighten a caliper bolt?
Your workers manual?
Workshop manual? Excellent. What chapter would I find it in?
Brakes.
Brake section, wouldn't I? So if you recall back to our read and respond to workplace information, we talked about workshop manuals a lot, didn't we? What section you need to find stuff in, where we're going to find it. But yeah, good work, boys. If we don't torque everything up to specification, what could possibly go wrong? Come loose. Exactly. We don't want brakes to fall off people's cars, do we? Because it's an emergency. It's safety number one. That's all we've got to stop in an emergency situation is our brakes. If the brake bolts are left loose, we could have a fatality, car crash, injure someone, injure ourselves. Could be a fatality, and we don't want that. So, torque wrench. Make sure it's calibrated every 6 months. Make sure you're aware of how tight it needs to be for the car that you're working on, because you can't just assume that every brake caliper bolt is the same torque, because some could be bigger bolts, bigger calipers, bigger braking systems, smaller. Little 4-cylinder cars have tiny little brakes. The bolts holding them on might not be that particular torque that you did on your Ford Falcon, might not be the same as a Toyota Echo. So always check with the manufacturer. So moving along, we just have a quick little 3-minute video we can watch on how the actual brake calipers work, how the hydraulic part of it pushes that piston out and pushes the brake pads onto the rotor, and how that clamps the wheel and stops it from turning, starts slowing it down, stops it from turning. So we'll just click on that and we'll just watch this quick little video.
Welcome to Bendix Brakes. Today we'll look at how a modern disc brake system works. We'll start by looking at the brake components involved in stopping the vehicle and how they work together. Starting with one of the main components in the braking system, we look at the disc rotor, which the brake pads squeeze against. This will create friction that decelerates the rotation of the wheel and the vehicle. The caliper is activated by the brake fluid hydraulic pressure produced from the vehicle's brake pedal and master cylinder. In this assembly, the brake pads are squeezed up against the disc rotor surface to create friction. A caliper is made up of multiple parts, all critical in the effective operation of the brake system. These parts include the caliper and mounting bracket, slide pins, locking bolts, dust boots, brake mounting clips, brake pads and chips, the brake piston with the dust boot and seal. The caliper is fed brake fluid through a banjo fitting, which drives the piston forward towards the inside brake pad when the brake pedal is pushed. This causes the caliper to move along the slide pins, which then pulls the outside brake pad up against the brake disc rotor. Now that we understand the parts, let's see how the braking system works. Hydraulic brake pressure will cause the caliper to move along the slide pins, pulling the outer brake pad against the opposite side of the disc rotor, causing friction and decelerating the brake and the vehicle. When the brake pedal is pressed, the caliper will receive high pressure brake fluid from the master cylinder, which will push the piston into the inside brake pad and onto the disc rotor surface. Looking at the braking process from another angle, we can see the brake fluid pushing the piston, which in turn pushes the inner brake pad against the inside of the disc rotor. Once this has happened, the fluid will now push the caliper along the slides and the outer brake pad will be pulled towards the opposite side of the disc rotor. Thanks for tuning in. We hope you've learned the fundamentals of how Bendix brake pads work with a modern braking system. And always remember to fit Bendix brakes.
That was a pretty good video, wasn't it?
Yeah.
Showed us exactly how brake pads work under hydraulic pressure. That particular caliper is called a floating caliper. So when one side is fixed and the other side slides, they call that floating. So when your inner pad is pushing against the rotor, that one touches the rotor first, and then that action, hydraulic action, forces the outside to come on and start slowing the rotor down. So if you get brakes, your inside pad is probably going to be worn a little bit more than the outer, unless you've got caliper issues. If you have seized caliper slide and that outside's not working, then your inner brake pad is going to be worn a lot more than your outer because it's not sliding. You're still going to be braking because the pad's going to be pushing on, pushing it into it, but that other bit's not sliding. However, you're going to have overheating brakes. So, overheating. When you're using your brakes like that, we are creating heat, we're transferring heat, it's heat energy through the coefficient of friction. So the number one thing that causes brake rotors to heat up, crack, is overheating brakes from a problem with the brakes, or your brake fluid boiling point has gone below the manufacturer's specifications. So do we remember hygroscopic? So what does that mean? What does that mean in brake fluid? Absorbs moisture. Valen, you're taking a lot of notes there, good man, well done. So hygroscopic means something that absorbs moisture. Your brake fluid will overheat, it'll probably evaporate, turn to steam, and you'll have no brake pedal, and that'll cause issues with your rotors overheating. So, specialised brake tools, we'll keep moving on. That top picture up there is a vacuum brake bleeder fluid for changing the fluid. It works on vacuum, so as you're pressing it in and out, it's sucking the brake fluid through the lines and getting rid of all your old brake fluid. So every time we've got to change the brake fluid because it's been contaminated or it's more than 2 years old, we need to flush the whole system out, and we normally use brake bleeding tools like that because it makes our job a hell of a lot easier. So when we're bleeding the brakes, which wheel would we start off with first?
The furthest away from the bridge.
The furthest away from the master cylinder. Well done, Seth. So you've got to start with the furthest one away. So because you've got all that old fluid from the front all the way to the back, there's no point starting at the front until you've got all that old fluid in the lines all the way to the back. So left hand rear, furthest away, then we will go right hand rear, then we do the left hand front, right hand front, same side as the master cylinder. But we also don't want to run out of brake fluid in our master cylinder, otherwise we're going to introduce air. So we've got to have someone always checking, making sure that we're topping it up. There is numerous other ways. You don't need that fancy schmancy brake bleeder. You can do it with 2 people. That's just to save time. So you could have one person in the car pumping up the brakes, another person opening the bleeder, getting all the old fluid out and doing it one at a time. That's a bit time consuming when you're in a workshop. I've got more fancier ones than that. Ones that actually work on compressed air. Venturi just sucks it all out. So there is lots of different ones. There's pressure bleeders, there's all sorts of stuff. The other one, other picture up there, caliper piston tool. You can see that, everyone see that picture? Is that clear? That's the tool there that is pushing that piston back into the caliper housing so that we can fit the new brake pads. Because as we know from that video, as the pads are wearing, they're coming out and out. Every time they wear down from braking, the more the piston comes out. So when you put new pads back in, if you just put your new pads in without pushing that piston back, it's not going to fit over your rotor. You won't be able to get it on because the piston's all the way out. So we need to push it back in so that we can put the new pads in and it fits over our rotor. Driveline wrenches or brake pipes or tube spanners, you guys know what they are, don't you? So we've used them before. They're a special spanner for undoing brake lines. So you don't round off the brake tube, which will turn into a nightmare, won't it? So you can get manual pressure bleeders, vacuum pumps, which that one is, electronic bleeding systems that remove air from hydraulic lines efficiently. Sometimes you've also got to use the scan tool to bleed brakes, especially if you've had ABS module off a car. So ABS, anti-lock braking system. So sometimes we also have to use a scan tool and we have to activate the solenoids in the ABS module to actually bleed the ABS module. So proper training, you would need proper training for that. It would be dealership specific for that particular model, because not all of them you have to do that, so depending on the car. So proper training. You can always do extra training if you have to, if you want to get yourself more qualifications. It's always good to think outside the square. Do specialised training courses. Rightio, equipment for inspection and serviceability. So measuring tools. We have micrometers. That one there says digital micrometers. Digital makes life a lot easier for us, doesn't it? This is not a digital micrometer, so we would have to, work out what the reading is, which isn't hard, is it? No, it's not hard. However, digital equipment makes our life a lot easier, makes everything quicker. All you got to do is make sure that it's zero. Is that on zero, Brian?
Yep. Oh, now
It is now, isn't it? It was on 0.01, wasn't it?
Yep.
So if we didn't zero that, we would get a false reading. 0.01 is not a big amount, is it? 0.01 mil. Not huge, but it might be the determining factor of whether or not something is undersized or not, and is going to cause a fatality. So we've got micrometers, we've got verniers, we've got dial indicators, digital calipers. Well, that's the digital calipers right there. They do make everything digital. You can get digital micrometers, you can get a digital dial gauge. It's all about going with latest technology and making everything easier. There's nothing wrong with that. That's why they invented calculators. I never used a calculator in my life till I was about 25 or something. But now you basically have to know how to use a calculator in primary school, I believe. Is that true?
Yep.
Rightio, visual inspection tools. So we're going to want a lot of light. We're going to want LED lights, torches, mirrors. If you have to get a mirror to look behind something for damage, they're pretty good. Brake pad wear gauges. Now, I have seen brake pad wear gauges. They come in different styles, and different colours. Some of them are green, yellow and red. They got different sizes on them. I don't actually have one here to show you, but green would mean good to go. And green means go. We're good to go. Yellow would mean warning, warning, we're getting down. Red, what does red normally mean? Stop, danger. So those brake pad gauges, they're colour coded, and you put them up against your brake pad and you check to see if they're at the same level. If they're green, they're good to go. If they're in the yellow, then yeah, look, they're getting down. You might want to inform the customer, hey, look, your brake pads are getting low. Next service, you're probably going to need to replace them. We sort of pre-warn people. But if they're down on the red, then it's like danger, danger, the sky is falling. You need to change them. However, I prefer to use these. It's just as easy. So we've got our depth tool for measuring. These are brand new pads. What does that tell me, Brian?
7.03.
7.03 millimetres. So these are brand new, aren't they? They haven't been used. So 7 mil. So 7 mil for a new brake pad. And what's the minimum thickness?
3.
3. So we've only got 4 mil of brake pad. Usable brake pad then, haven't we? We got 3 sort of backup. You know, we've still got just under half the pad left over. So we've still got 3 as backup, but 4 mil of brake pad does not seem like a lot, does it? So it goes to show you, because most brake pads will last 40,000 k's, depending on how you drive, 40 to 50,000 k's. So if we've only got 4 mil of brake pad, usable brake pad, and they're worn out by 40,000 k's, what does that tell us?
Need to change?
No, we use them, what, 1 mil every 10,000 k's? That's not a lot, is it? For the job that it does. It stops the car, it slows the car down. 120 k an hour, and you know, you've got to brake because the truck's coming sideways at you. 1 mil every 10,000 k's. Amazing, isn't it? That one's at 4, by the way. So that one's all good, still serviceable. So we've got visual inspection tools, lights, mirrors, brake pad wear gauges, fluid testing equipment. Why do we need to test the brake fluid? Anyone?
So your brakes can work.
Well, we need to test it to see if it's contaminated and got water or moisture content, because that affects our braking performance, doesn't it? So we need to check the moisture content. We've got things for doing that. We have boiling point testers. They go in the brake fluid, they got 2 little electrodes on them, and they will test the water content in the brake fluid. They work on voltage, and the higher the voltage, that means the more conductivity of electricity, which means there's water. The lower the voltage, that means there's less moisture present. So you can use a boiling point tester, or if you don't have a fancy schmancy boiling point tester in your workshop, you could use a multimeter set to 20 volts. One probe in the brake fluid, your earth probe on the earth of the brake master cylinder, and it shouldn't be more than 0.03 of a volt. If it's more than that, we've got moisture in it. So you don't need a boiling point tester. Everyone's going to have a multimeter in their toolbox. You can get test strips that you dip in. A bit like coolant test strips, you know, when we're testing coolant, see if it's any good or not. The ethylene glycol, brake fluid's got the same. Remember when we done cooling systems and we used that refractometer? telescope. You can actually get refractometers for brake fluid, which does the same thing, similar to coolant. Coolant checks the ethylene glycol. Brake fluid refractometers check for moisture, and you can get them for car batteries, can't you? Because ours actually tests for car electrolyte, doesn't it? When you look in that screen, you've got battery-specific gravity. So there's 3 testers we can use: boiling point tester, test strips, multimeter, refractometer if your workshop has one for brake fluid. So we always got to make sure that we regularly calibrate it and make sure they're in good working order. So how do we control our tools? Like, how do we know if we can use them or not? Inspect them. Inspect them for damage. Tag them out if you have to. Inform your supervisor. Always make sure your verniers, when you're measuring something, they're not damaged. If you're using a micrometer, before we even take a measurement, what do we need to do?
Reset it to 0.
Zero the device. Look, Valen. Well done, mate. We've got to make sure it's on 0 before we even start. So we've got to 0 the micrometer. And how do we do that? Just throwing it out. One barrel, a special tool to little hole in the barrel there. You turn it around to 0. Well done, guys. Starting to surprise me. I'm getting scared. You know too much. Rightio, safety gear in the workplace. Safety goggles. Protect our eyes from debris, fluid, especially brake fluid. You don't want that in your eyes because we know what it can do to paint, don't we? It takes the paint off. Airborne particles, chemical resistant gloves to prevent skin contact with brake fluid, or brake clean for that matter. Brake clean will dry your skin out. Respirator mask when working with older brake components that may contain asbestos. How do we know if they've got asbestos or not? We don't. So what are we going to do, Brian?
We're just going to work it like it does.
We're going to assume that everything has asbestos in it. Thank you, Brian. Well done, mate. Steel-toed boots for foot protection. You remembered that from last week, didn't you? Obviously, adequate workshop requirements, lighting, proper ventilation. We need that. Brake dust, vacuum, HEPA filtration. We need to support the equipment. So safe working loads, axle stands, lower the hoist onto the locks. So we've got an initial assessment, check for fluid leaks, inspect for cracked components, check for damage, troubleshooting. We got brake pulsation. That's when you put your foot on the brake and your steering shakes or the car's vibrating. That means our rotors are warped. Excessive noise, squealing or grinding could mean brake pads are worn out. Spongy brake pedal means we've got air in the system. Vehicle pulling to one side when braking, that means one of our brake calipers is not working properly on the other side. If your car's pulling left when you're braking, that means your right hand front one's not working. Troubleshooting caliper issues, seized pistons, they need to be disassembled, cleaned, overhauled. Rotor problems, warped, they need to be measured, machined or replaced. The cost of them these days, you can just replace them. Identifying component wear, obviously have a good look. Check the rotors for deep scoring, cracks, discoloration. Select the right tools, make sure you document everything. Make sure everything's tight and make sure you double check everything. Have someone do a quality control check. Righto guys, that basically brings it to an end. There is a quick quiz everyone can fill out. And then we'll do the feedback forms. There you go, pass one down, take one, pass one on. And you guys should be able to whip right through this. Removing brake calipers. First question. Anyway, thank you. I forgot to mention Malcolm Race, the third-party observer, my Cert 4 training and assessor guy. Thank you, Malcolm. Thank you for being present.
Thank you, Ronnie.
That looks pretty good, Brian. Well done. All done. Valen, you little champion. Alright guys, we'll go through the feedback form. You can just fill that out at your own will. And we can wrap up for today. Thanks guys, thanks for coming.